What's up, YouTube? This video is going to be a fun video where, as you can tell from the title, so you think you know C#. Well, let's see. This is a fundamental kind of video, and I love to make some of these videos because I find that it's the fundamentals that people are kind of shaky on. You know, they kind of sort of know the answers, but they don't really have a good grasp of what it is. So if I were to try to confuse them with another question, they would actually get confused. In other words, if you know something really well, you can't be confused when somebody asks you confusing questions, right? And so this video is going to hopefully iron out some of your confusions if you have them. If you think you know, please continue to watch because maybe you'll learn a few things that you didn't know or didn't know that well or didn't quite understand exactly how or why something is happening, all right? Nonetheless, enjoy. So we're going to start with a few things in this video. That is, we're going to be looking at, in no particular order, by the way, just the strings and immutability and what it actually means and why are they immutable, and is C# the only language where strings are immutable. We have reference types, value types. I know some of you think you know the answer to what is the reference type and what's the value type. It's wrong. I can just tell you right away. And passing by value, passing by reference, and some of the anomalous behavior that occurs when you do that. You may take it for granted if you've been doing C# for a long time, but you may not be able to explain it. So that's the point of this video, is to explain some of the underpinnings or the fundamentals of what's going on. In all these things that are seemingly very simple, beginner level things, I just think that even though the beginner level, you kind of skim over it. And then, 5 years later, you still don't understand what's really going on. And that's the point of this video. All right. Okay. So let's start with value types and reference types. So if I were to ask you, what is a value type and what is a reference type? The typical answer I would get, maybe not from you, but from most people, value types are allocated on the stack, reference types are allocated on the heap, and that sort of ends that conversation. First of all, that's wrong. Value types are allocated in line. Reference types are always allocated on the heap. What does inline mean? Well, we'll get to that. So the right answer is value types are allocated in line. Reference types are always allocated on the stack. Okay, so we're going to examine that statement. Hopefully, you'll get a sense of what I mean when I say inline versus on the stack. So here I have some C# code, and I have a value type that's been assigned a value of 20. So when execution comes to this line here, you will find, because this is a local variable, the I variable is allocated on the stack. And if I went to look at that address space, I'd find the value 20 there. Value types, the variable of the value type is the value. In other words, when I go to this location where the variable I was supposedly allocated and I look at the value there, if I look at what's in that at that address, I'll find that the value 20 is at the address, right? So in value types, the variable is the value. In reference types, the variable is the reference. So that's one key difference. No matter where you dice it, or wherever it's allocated, with value types, the variable is the value. And what I'm trying to show that, over here by saying, here's a local variable I. It is allocated on the stack, but at this address. But when I went to look there, I'd find actually the value 20 there. So the variable is the value. Let's look at the string. So allocate a string local variable. Strings are reference types. They will always be allocated on the heap. Right? But the variable s will be allocated on the stack because this s is a local variable. So if we go into on our stack here for the main method, you'll see this variable s is there. It's at this address. And when I look at the value of s, it has got the value of another address in memory. This address is on the heap. And that's pointing to this location here. And here is where we have the value of the string. So for reference types, the variable is the reference. For value types, the variable is the value. Okay, that's the one distinction between value types and reference types. Now, I have a struct. All structs are, yes, exactly, value types. And all the properties in the struct are also value types. So you can see here all the properties are also value types. So when I new up this struct, this info is again a local variable. So the variable itself will be allocated on the stack. And that's what we have here at this address. And if you went to look at this address, you'll find that its members are also allocated, but they're allocated in line. They start at that address, but they're all allocated in line. They're all part of that object, right? That instance that's in this case on the stack. Because all the properties are also value types. They're all allocated in line. All right. So if I went to look at the location for that variable's, the member's address, I'll find the value in that location. In other words, here you would find, so this is, let's say, 8 bytes. So let's say the double value will be found here. The date time value will be found here. And the ID value will be found here. They'll be found in location, in line. All right. So even though this struct is allocated on the stack, the variables, the members that are also value types are also allocated in line, happen to be on the stack. Okay. Now, a little change. I've taken the same struct and I've added a reference type property or member here. All right. So same thing occurs. This is a local variable. It also happens to be of type struct. So in that location, you will find the value, and the value in the case of a struct is, of course, everything that it contains. And once again, you'll see that there's, let's say, this is the value property or member. This is the date member. That's the ID member. And this one is the new string member. But what you're finding here, because the string is a reference type, the variable is not holding the value. It is holding the reference. In other words, that is a pointer to a location in memory where the string would actually be allocated on the heap. The struct itself does not contain the value. It only contains the reference, right? So then when I allocate or set a value to the member, to the name property, I get the address to that string on the heap. So the variable or the member, name member, is holding a reference or a location, memory location for that name string itself on the heap. All right. The values are still inline, but in the case of the reference types, what's inline is the pointer location and not the value itself. All right. Now, change it again. This time, this info is a class. It's not a struct. In other words, this is a reference type now. So when I new up an instance of info, even though info is a local variable, this info local variable will be assigned, allocated on the stack, but its value will be the address location of the object on the heap. All right. So now, because that's a class, not a struct, it's gone on the heap, and the variable doesn't have the value itself. The variable now has a reference to where that object is actually allocated on the heap. Okay, that's the big difference between the reference types and the value types. When I assign the value, the name to a certain value, hello here, also notice, by the way, that this location is the starting address, let's say, of this object here. And these value types, the double and the date time and the ID, the int, are allocated in line on the heap, right? Which is why we say value types are allocated in line. They're not necessarily allocated only on the stack. They're allocated in line, in situ or in line. All right. So because this reference type starts here, its properties are allocated. The value type properties are all allocated in line. Again, because this is a string, it's the same thing occurs here. This member, the name member, only contains the reference or pointer location to the object, so some other location where the actual object is allocated, also on the heap, and this location points to that. So for value types, all properties in this case are allocated in line, but this reference type is allocated on the heap, but the reference type variable is not the value, it's the reference or the pointer location to the actual object in memory. And so this name property here is just holding the address of the actual object, string object, allocated somewhere else on the heap. Right? You don't know where it's going to be. It's just going to be somewhere else on the heap. Okay, so hopefully that has cleared up the confusion between, not necessarily confusion, but how to get at the right answer. Why do we say the value types are allocated in line? They're not allocated on the stack. They're allocated on the heap as well and on the stack. So they're allocated inline, in situ, wherever they need to be allocated. Reference types can contain value types. So if a reference type contains value types, then the value types are allocated inline to the reference type, but the reference type will always be allocated on the heap. Therefore, the whole thing is on the heap, and the value types are contained inline of that reference type. Okay, hopefully that makes some sense. So if you understand value types and reference types, then what about passing by value and passing by reference? So we'll look at a couple of examples. I'm going to skip maybe some of the basic stuff. Let's take a look at what do I show you here. Yeah, so I've got a simple program here that has got a local variable of int, and I pass that into a method here, and this int or this argument here is passing. In C#, everything is passed by value by default, unless otherwise specified. All method arguments are passed by value. What does that even mean, passed by value? A copy is being made from here. So this method is trying to call this method. In order to send this method the argument, the runtime has to make a copy of this value. So it's a 10. So it'll make another variable and pass it here with the same value. It has to copy the values over. Imagine a struct that is, let's say, comprised of only value type members, but it's huge, it's big. If you want to pass that struct from method A to method B, the runtime has to make a copy of every property and then send that across to the other method. So it's passing by value also means making a copy of the variable, because in value types, variables are the value. You're copying all the values over, be passed on to the other method. So a copy is being made. Okay, so it's not necessarily expensive, but it can be expensive to make a copy of a large struct. So when you have structs, your aim should be to have smaller structs in terms of the memory requirements for a struct. So when it comes here, if I were to change this value, let's say I is now equal to 20, it's not going to change. I won't run the application because I'm guessing this is all very simple stuff for you guys to understand here. When I pass the integer by value to this method, I change the value to 20. When it comes back here, this value of I has not changed because a copy of I was made to send across to do something. The actual value was left behind, and so it was untouched. This method modified the copied variable, and it's probably thrown away because you're passing it as a copy. So you're not supposed to say, okay, I'm going to give you a copy. Let's say you want to borrow a book from me. It's okay, here, I'm going to make a copy. Let's say a printout. Take the book. What do you want with it? I still hold the book, the original book. I'm not concerned with what you may or may not do with the printed paper. That's your problem. That's what passing by value is. If I pass this by reference, however, so I have to mark this method such that it expects this by ref, and the call side also has to be marking this as ref. So it's clear on both sides that you're passing this by ref. Now you're not making a copy. The actual variable is being sent across to the other method, not a copy of it. So now when I modify it on this method here, when it comes back, it's the same variable that was modified by the do something method. Therefore, it also has the value 20. As or not, it also has. It holds the value 20 because it was modified by the other method. So for value types, passing by reference seems like, well, if you want to change it, you pass it by reference. Right? In other words, don't make a copy. Send the actual reference, the variable, the address location of the variable to the other method, and let that method then modify it, since the variable is the value. Right? Okay. Let's say we had a string here instead. So let's say this was S1, and I said the value hello. Right? And here I'll change it to, I'll start by passing by value first. All right. Okay, so here we pass in S1, and then here we print S1, the console. Okay, if you've been doing C# for a bit, you know that the value of S1 will not be modified in this case. No? Are strings value types or reference types? Reference types. So when you make a copy of a reference, are you sending a reference type, the pointer, or are you sending the actual value? What are you doing? If you're passing by value, a copy is being made of what exactly? The pointer reference, not the memory location. So in other words, there are two pointers now. Originally S1 pointing to some memory location. And now it's trying to pass that by value to the other method, do something. So it makes a copy of S1, but S1 is not the value. S1 is the reference to the pointer location or pointer address to the actual object. So a copy is nothing but a copy of the address, right? So when it comes in here, it's not modifying necessarily the address location, it's modifying the actual object at that address, is it not? Okay, so what do you think the answer is going to be here? Now, some of you might say it's going to be hello world. Some of you will say it's hello. Can you explain if it's hello? Why is it hello? Because if you understand passing by value is making a copy of the variable, but the variable is the address location. So why is it not working? Do you have the answer here? The answer to that is nothing to do with value types or reference types. Strings are weird. And because strings are immutable in C#, this behavior occurs. The behavior that's going to happen here is that you will still see hello, you won't see hello world, even though you passed a reference type to a variable, to a method as an argument, and the method modified the argument. Because as a reference type, you would expect it to have been modified. Now, if you say, well, I know it's not going to change it, the question is, do you know why it's not going to change it? Right? That's the learning part here. Because strings are immutable, the moment you try and modify the string, it has to make a new string. It leaves the old string there. It makes a new string, right? So if you can imagine here, this is S1 pointing to some address location A, let's say. And then you say, okay, I'm going to make a copy of this. So let's call it S2. And S2 also points to the address location A. S2 goes along to the other method, do something. And now do something wants to modify this location. And the runtime says, hey, hang on. There's this guy that's pointing to the same location. S2 is also pointing to the same location. Now you're trying to modify S2, but you can't modify S2 directly because strings are immutable. So now it's going to allocate a new string, copy the data from the original address A to the new address B, and point S2 to the address B. S1 is still pointing to the address A. It's not because they're reference types, it's because they're immutable. So this behavior is expected. It might be confusing, but it's expected only because strings are immutable. If strings were not immutable, you would see hello world as your output here. All right. So is that any different from, let's say, over here? So let's say I do var S2, and I say S2 is equal to S1. And then I say S2 plus equals world. What's the difference now? It's the same. The output will be the same. In other words, just because I send something by value or by reference to a method in the case of a string, that's not what's making the difference. The reason the behavior occurs is because strings are immutable. They have to be reference types, but that's not either helping or causing the problem. It's simply that strings are immutable. Now, string immutability is, I know people understand conceptually that strings are immutable, therefore you can't change them, but you can change them. So then what's the problem? I mean, why do people keep saying strings are immutable when you can change a string as much as you want? There's a cost you pay for that. So imagine this. You have a string, variable, pointing to something in memory. Let's say address A in memory. And address A has this huge object, huge string. Let's say, 1 meg string. This as an example. And now you want to add one more character to that string. The runtime has to make a copy of that string with additional memory space to allow you to add that one character. It can't do it in line. It can't do it in situ. It can't modify the existing string. Strings are immutable. So when you concatenate a string, it has to allocate enough memory in a new location for that larger string, move all the data from the previous string to the new string, By move, I don't mean like move it from there, make a copy rather than move it. Making a copy of that data from there to here to the new location, and then adding that additional string that you want to add. That's expensive. From a memory standpoint, now you got two strings in memory that are almost the same. The amount of time it takes to copy all the data from the first location to the second location, right? So that those two operations are expensive. And of course, then because you've added garbage, that S1, let's say, will be eventually collected, that's going to cost you as well. So concatenating strings have a cost. Now, that's not to say you shouldn't concatenate strings, okay? Because if you've seen my benchmarking video, you'll probably notice that in some cases, string concatenation actually is quite a bit faster. So there are times when you should concatenate, and just because if you're looking at how much memory is allocated or how much faster things are, string concatenation is not necessarily bad, but you need to understand what's going on or what it means. When we say in C#, strings are immutable in C#, which means anytime you want to modify a string, you have to first make a copy in a new location, move all the data from there, copy all the data from the original location to the new location. The previous location may be garbage depending on what you're doing with your code. So that has to be collected. So that's going to eventually cost you because garbage collection does cost us. And then it can allow you to modify that string. All right. Anyway, going back to this here, we have a string that even though it's being modified, S1 will still hold the original value because as soon as you modify the string, it has to make a new string. So S1 is still pointing to the old location. S2 is pointing to the new location. There is a string that's got the value hello world in it. We don't see it anymore. It's gone out of scope from after this method. But it's there in memory, and the GC is going to have to collect it. But you're not seeing the value on your method here. Okay. So let's say we pass it by ref. Or even before we do that, what if I had this object here? So here I've got an info object. It's got a few value type properties, and it's got a name, let's say reference type. So let's say I want to pass in info to this method here. All right. And here we just say what does it need? It needs ID. It needs a value, date time, and a name. So let's say, all right. And then we pass that to this method. And we can print out, I'm only interested in this point, the name property. So that's the reference type. All right, then in this method here, my mic's coming in the way of my screen, so I'm having a hard time seeing the screen with the arm is interfering. So I'm just going to say info.name is equal to, let's say, Jack. So what happened now? What would be the output here you would see? Remember, strings are reference types. This info is a class, so it's also a reference type. What is the outcome of this? Can you tell me? Okay, so if you guess that the name will actually change, now you would, the thing what I found is most C# programmers would know the name would change. They just know that. They just can't explain it. Why has it changed? Because I showed you just earlier that when you send a string to a method, it won't actually change the original, right? It'll make a new allocation and modify that new allocation, and the older allocation or the previous allocation will remain intact. Why is it changing here now? And that's where, some of the confusion arises. I'm going to show it to you, try and explain it to you by way of some diagram. All right. This is a sort of typical, this is a conceptual model, by the way. This is not like exactly the real way in which things happen in .NET, but a conceptual model. So you can help kind of visualize things in your head. Anytime I say, you're creating a new instance, you can visualize this kind of a diagram in your head to say, okay, that means all this memory was allocated, right? So we have the storage for ID inline. So this is the pointer location, variable pointing to this location. This is at this location, you have all this data, right? You have the storage for the ID, which is an int, storage for the value, which is a double, storage for the date, which is a date time, and now a pointer to the name, right? Because this is a reference type. These are value types that are allocated inline. This is a reference type, is allocated on the heap, but you got a reference to the actual object. This object, hello, is an object. Think of it as another object like that. Strings are allocated in memory in a slightly different manner. Strings and arrays in C# are almost the same, but they're not like some of the other types that we have, reference types we have here. But for a reference type, this is sort of the kind of memory that needs to be allocated for a reference type. And because this property is also a reference type, in this case, we hold the address location here in 4 bytes, but that is another object. I'm just simplifying it by saying hello here, but this is a whole other object. So it's kind of got similar complexity to it, if you will, right? All right. So now, in the case of now object, you're saying, hey, so-and-so object, please change your name from Shiv to Jack. Name is a string. Strings are reference types. The name pointer is a pointer to a location in memory. When we assign it a new value, the object takes care of it. And the object says, oh, you want me to change my property name from Shiv to Jack? Okay, I'll create a new string. I'll point the name property now to the new string. And that Jack string has to be the Shiv string has to be eventually garbage collected. It's not something you have to manage. You're not working with the raw string. You're working with an object that has the string as a point, as a property. And so the object is managing that swap, if you will. So when you say, hey, info object, your name is assigned to Shiv, it says, okay, I'm going to assign a new string somewhere in memory, and the name will point to that string location. And then I say, hey, info, your name is now equal to Jack. It says, okay, I'm going to have to allocate a new string, put the value Jack in there, and the name property will now point to this new string. So it's not like the string was suddenly mutable. It does the same operation. It creates a new string. The Shiv string will have to be garbage collected. And now the name property points to the Jack string. Jack string. Shiv string. Weird. Sounds weird. But the object is doing that. You're not doing it yourselves. Right? So when you look at the code here, when I make this modification of code, I've made this immutable. So it's complaining. So this is going to set the name to Jack. When you come back here, it's actually going to print Jack. Isn't it weird? It's like when you had a string, it's not the same behavior, but the moment that string happens to be in an object, it suddenly starts to work the way you expect. Now, I know most people have experienced this and they use this, unfortunately, to their advantage when they write code, but they can't quite explain it. And that's the whole point of this thing. I was trying to explain some of the reasons for why certain things happen and don't happen. And so hopefully this explains to you passing by value. Oh, we haven't done the by reference here. So if I did it by reference here, there won't actually be any difference or change in behavior. Right? This will be the same outcome in the sense that it's being managed by the object here anyway. So yes, you sent a pointer. You sent the actual pointer. You didn't make a copy of the pointer and send it across initially when this was not by ref. The call side here, not here. The call side here would make a copy of the pointer location. So both variables are pointing out the same location. By ref, it's just passing the actual variable itself. So it's not changing much for reference types. This brings me to a bit of a pet peeve of mine that I have when people write code like this. I don't like to have code like this. If you're sending a reference type to a method, and the method is going to be modifying this reference type, I personally prefer to return that reference type. It's very clear when I look at the signature that, hey, if I send you some A, you're sending me back a B, and the B is probably the modified version of A. Now, I don't always create a new instance and return it, but that's an implementation detail. It could change. The signature of my method will say, I'm asking you for something, I'm going to return to you a modified something. So even though I know how reference types work, I don't use it and then confuse the whole thing by saying, okay, I'm going to send you a reference type, therefore I can just modify any property on it. And when you get back from my method, magic happened and you got new values. It's not clear. All right. So I don't actually like this style of doing it. I would actually change this void return to be saying, I'm going to return to you a modified info. Whether it's a new instance or an old instance is not so relevant. That implementation can change, but I don't typically create a new instance unless my classes are immutable. Like in this case, it was. I just modified the name property to not be immutable just for the sake of this example. Anyway, as I said, this was going to be a short and sweet video. I hope you enjoyed it. I hope you learned a few things. I hope some things were made a lot clearer. And I hope I also confused the heck out of you in some cases or some situations. That was the point. Baffle you, confuse you, or get you all excited about, oh my gosh, that's what happens. Anyway, if you enjoyed this video, please give me a thumbs up. Please hit the subscribe button. Please hit the notify button. And if you have questions, please use the comments to ask me the questions or tell me what you thought. And I will see you next time.